Machining vibrations, also called chatter, correspond to the relative movement between the workpiece and the cutting tool. The vibrations result in waves on the machine surface. This affects typical machining processes, such as turning, milling and drilling, and atypical machining processes, such as grinding. A chatter mark is an irregular surface flaw left by a wheel that is out of true in grinding, or regular mark left when turning a long piece on a lathe, due to machining vibrations. As early as 1907, Frederick W. Taylor described machining vibrations as the most obscure and delicate of all the problems facing the machinist, an observation still true today. As shown in many publications on machining, mathematical models make it possible to simulate machining vibration quite accurately. But in practice it is always difficult to avoid vibrations, and there are basic rules for the machinist. Rigidify the workpiece, the tool in the machine, as much as possible. Choose the tool that will excite vibrations as little as possible. Modifying angles, dimensions, surface treatment, etc. Choose exciting frequencies that best limit the vibrations of the machining system. Spindle speed, number of teeth and relative positions, etc. Choose tools that incorporate vibration damping technology. Industrial context. Link between high-speed machining and vibrations. The use of high-speed machining, HSM, has enabled an increase in productivity and the realization of workpieces that were impossible before, such as thin-walled parts. Unfortunately, machine centers are less rigid because of the very high dynamic movements. In many applications, i.e., long tools, thin workpieces, the appearance of vibrations is the most limiting factor and compels the machinist to reduce cutting speeds and feeds well below the capacities of machines or tools. Different kinds of problems and their sources. Vibration problems generally result in noise, bad surface quality, and sometimes tool breakage. The main sources are of two types: force vibrations and self-generated vibrations. Force vibrations are mainly generated by interrupted cutting, inherent to milling, run-out, or vibrations from outside the machine. Self-generated vibrations are related to the fact that the actual chip thickness depends also on the relative position between tool and workpiece during the previous tooth passage. Thus, increasing vibrations may appear up to levels which can seriously degrade the machined surface quality. Laboratory research. High-speed strategies. Industrial and academic researchers have widely studied machining vibration. Specific strategies have been developed, especially for thin-walled workpieces, by alternating small machining passes in order to avoid static and dynamic flexion of the walls. The length of the cutting edge in contact with the workpiece is also often reduced in order to limit self-generated vibrations. Modeling. The modeling of the cutting forces and vibrations, although not totally accurate, makes it possible to simulate problematic machining and reduce unwanted effects of vibration. Stability lobe theory multiplication of the models based on stability lobe theory, which makes it possible to find the best spindle speed for machining. Gives robust models for any kind of machining. Time domain numerical model time domain simulations compute workpiece and tool position on very small time scales without great sacrifice in accuracy of the instability process and of the surface modeled. These models need more computing resources than stability lobe models, but give greater freedom. Cutting laws, run-out, plowing, finite element models. Time domain simulations are quite difficult to robustify, but a lot of work is being done in this direction in the research laboratories. Paths. In addition to stability lobe theory, The use of variable tool pitch often gives good results at a relatively low cost. These tools are increasingly proposed by tool manufacturers, although this is not really compatible with a reduction in the number of tools used. Other research leads are also promising, but often need major modifications to be practical in machining centers. Two kinds of software are very promising: time domain simulations, which give not yet reliable prediction but should progress, and vibration machining experts software, pragmatically based on knowledge and rules. Industrial methods used to limit machining vibrations. The classic approach, the usual method for setting up a machining process, is still mainly based on historical technical know-how and on trial and error method to determine the best parameters according to the particular skills of a company. Various parameters are studied in priority, such as depth of cut, toolpath, workpiece setup, and geometrical definition of the tool. When a vibration problem occurs, information is usually sought from the tool manufacturer or the CAM, computer-aided manufacturing software retailer, and they may give a better strategy for machining the workpiece. Sometimes, when vibration problems are too much of a financial prejudice, experts can be called upon to prescribe, after measurement and calculation, spindle speeds or tool modifications. Limitations of the available methods compared to the industrial stakes. Commercial solutions are rare. To analyze the problems and to propose solutions, only few experts propose their services. Computational software for stability lobes and measurement devices are proposed, but, in spite of widespread publicity, they remain relatively rarely used. Lastly, vibration sensors are often integrated into machining centers, but they are used mainly for wear diagnosis of the tools or the spindle. New generation tool holders, and especially the hydraulic expansion tool holders, minimize the undesirable effects of vibration to a large extent. First of all, the precise control of total indicator reading to less than 3 micrometers helps reduce vibrations due to balance load on cutting edges, and the little vibration created thereon is absorbed largely by the oil inside the chambers of the hydraulic expansion tool holder. See also, balancing machine, shock pulse method, a high-speed camera capture of machining vibrations, modern machine shop article about machining vibrations.